So like imagine it's 2002, right? And like you're bummed out because your job at the startup, didn't pan out, and you still can't believe that the World Trade Center isn't there anymore. But you're talking to a friend of yours, and they're sitting there describing this thing called they're talking about this cool new idea called a wiki, and you're like, well, what's that? And they're like, well, it's like people can edit pages and make links, and it's a lot like everything too. And you're like, well, yeah, everything too. That's really cool. So maybe I should try making one of those. So, if Clinton was still president, you would probably make it in Perl and use like Berkeley DB or something on the back end, right? But like in the new century, you use personal homepage in MySQL. So you might do something like this to have your page to have your query on the database where you load your page. And this works out pretty well. Like, wikis are referenced by title, so you just sit there and query the title out of the database. Of course, if somebody were to type in something like this for the title, and I entity encoded the spaces, but not some of the other stuff, so you can kind of see it better, then like you're in trouble, right? Because now they can see all your users, and then you end up on /help because you used MD5s to hash the passwords, and now everybody has everybody's password. So well, that's pretty easy to fix, right? You just have to quit concatenating user input with the actual SQL command. And now we switched from PHP here to psychopg. So we're nicely into Python now, but you can see the basic idea here is you include this little formatting item, and then you pass in a tuple of your parameters, which here there's only one. And then this way, the database knows that regardless of what's in the title, even if it's some fake up SQL string, the database now knows, actually that's not SQL. Like, don't dare interpret it as SQL because it's being passed in as a parameter. So this is pretty cool, and this thing kind of takes care of the problem, right? Except you have to be in on the script. And it seems like a lot of programmers aren't. At least, I mean, this has been around for more, around a decade or so, and we're still getting SQL injection problems. So one thing we could say is that it would be better, perhaps, if the programmer didn't have to type in the SQL at all, and therefore didn't even get the opportunity to not parameterize it. Moreover, you have other problems, right? With that, suppose you get some funding, and then you find yourself no longer on MySQL because your investors told you need to be using Oracle. Or whatever, like you want to do a dev server on SQLite, or maybe you want to switch to Postgres because MySQL got bought by Oracle. So so the problem, the ultimate problem here is I'm pointing out is that there's a lot of syntactual incompatibilities between major database engines, and if you're sitting there writing a lot of raw SQL strings, you're going to run into them when you really shouldn't. I mean, and Oracle's got some bizarre syntax, but even MySQL and Postgres obviously differ a lot on how they handle quotes. So like a simple thing like that, you can end up with thousands of changes just to change the database backend. Okay, yeah, so here's another issue. Suppose your application gets a little bit more advanced. Suppose you need an admin system, and you want to see, you want to have a particular view that shows you, in this case, all your active users or all your logged in users, or maybe both. And you want to do through some kind of form entry or a get parameter, you want to be able to modify those or toggle in between them. Well, this is about the cleanest code I could come up with to actually do that if you're concatenating strings together. And you can see, I mean, it works okay, but I have to do some weird stuff. Like I had to fake up the where clause. Actually, you know what? And that's not even going to work, is it? Because so as you can see, like this is a tough thing to do. The and should have been down there in what the appends. Each append should have an and in front of it. But yeah, okay. Obviously, I just demonstrated my point that sitting there trying to generate SQL expressions that do various things by concatenating strings really sucks. Okay. And then the final problem with this 2002 way of doing things is that the result set's a really crappy data set to use. And here I use an example. We do a simple join where we have a user table and say a phone number table where the users can have multiple phone numbers. And so that's pretty straightforward. This is obviously Postgres syntax. Well, maybe not Postgres, but Postgres accepts this. Postgres accepts a few others do. Right, exactly. And yeah, exactly. And And you're going to be editing this part out, right? So. Yeah. Okay. So yeah, this does suck as much as PowerPoint for sure. Well, F5 is not working, so I'm just gonna. You guys are just. Well, you can't see what's coming up anyway. Can I get rid of? There we go. Okay. So fix the ORM. Okay. Yeah. So here we go. So this is what we use now, right? The object relational mapper. If you're using Django, or if you're using any kind of modern Ruby on Rails, any kind of modern framework, you're using object relational mapper. And the nice thing about it is it fixes all the problems we just went over. Here we see this is using the Django ORM, and you can see that parameterization happens automatically. So you no longer have to depend upon the user or the programmer rather to just know that he's supposed to parameterize user input, because that happens automatically when the code generator runs. For generating SQL, here's the example that I showed a minute ago, where we're trying to concatenate strings together to show either all users, active users, or logged in users, or logged in and active users. And here on using Django, that's actually a lot more straightforward, and I think there's even not any syntax errors here, so which is an improvement over this string, right? Okay, so oh yeah, so and then here we go with respect to the result set object. You can see that we've also fixed the problem with the result set object, where joins become very awkward because they result in duplicate entries. Because the object relational mapper, as its name suggests, maps a user object to maps database data to native objects. It can take care of the complexity of dealing with the results set data. And here we have we're able to fetch the user named Bettis. We do a count on it. We see there's only one. It didn't return two objects because there's two phone numbers, and then we can access the set of phone numbers. Okay. Now the problem with the ORM is that things that used to be easy have suddenly become very difficult or impossible. Here we have a query that's trying to access a feature of PostgreSQL that the Django ORM doesn't support, right? PGP-SymDecrypt is a function of pgcrypto, which is a system that allows you to encrypt information in the database. And I actually use this example because I had to work on this with a client. They wanted things encrypted in the database, and they wanted to use pgcrypto to do it. And they weren't coding on a slideshow program, so it was slightly more sophisticated than the code you see here. This is more of an example. But the problem was there was no way to do this at all in the Django ORM. It just wasn't built to do this. So what I ended up having to do is make an extension of the Django ORM that accessed the internals of the code generator and inserted these terms. I mean, if you think about it, it's a relatively easy thing, right? I have a column. And if I access the column, I just want to wrap that little database function around it. But as it turns out, that was a very difficult thing to accomplish in the Django ORM. And once I had it done, because it used private APIs, they kept on changing. So every time we upgraded Django, I had to go in and fix this again because it would access one thing or another that they decided to change. And then the final problem is we've lost our ability to edit or to control the actual SQL that's being generated, and also to control how it's being inserted into the database. And I use this example because this has been a problem. This is a very simple example, but it's been a problem for years in Django, and it was only fixed in March of 2012. And the problem is, what if I want to insert a whole bunch of items at once into the database? Well, with the Django ORM, up until just March of this year, the only way was to iterate through the users and insert them and save them one by one, which is a round trip to the database every time. And now, of course, you can bypass the ORM, which a lot of people do, but then you're back to writing raw SQL. So the moral of the story is, by going to the ORM, we've gained a whole bunch of things. We've gained a whole bunch of very important things. Automatic parameterization, which is very important for SQL injection, prevention of SQL injection attacks. We're no longer dependent upon a particular database syntax because we don't have to actually write the SQL, so we don't have the opportunity to pick a particular syntax. We can easily program it. I don't need to read this whole thing, but you guys get the idea. But we've lost the ability to access features that the ORM doesn't support, and also the ability to optimize queries. So I think that the problem with the way the Django ORM is organized is, and I think most ORMs that are in existence right now, is that you have the ORM API, and if it works, it works. If it doesn't, it doesn't. And if it doesn't, you're back down to accessing the raw backend and typing in raw SQL. You think there's a broad middle because you have to wonder, like, how does something that starts off as native objects end up as SQL, right? There's got to be something in the middle there, but it's just all a blank map. So we can kind of like pierce into like the blank map a little bit with just like a tiny little bit of theory, and very little, I promise. But if you consider this problem here, and you're given the opportunity, or you're given the assignment to calculate this value, you might start out by saying, okay, I'm just going to iterate from the left to the right. But of course, that's going to give you the wrong answer. So then maybe you say, well, if you're very clever, you might say, well, like I'll use a regex and fetch that little parentheses out and do that first, which, I mean, would obviously work on this one, but it wouldn't work in the general sense. So like the real answer to processing, to solving a problem like this, is to take this value, to take this expression, and to turn it into a tree. And this is called an abstract syntax tree. But the idea is you can imagine this existing in Python code, right? Like you make a class expression node, and then maybe a class like operator node and value, and then you can sit there and give them children, and you can sit there and assign, children. So I hope people can see like this would be a really easy data structure to express. But the question is, how does this get us to the point where we can sit there and calculate the above function? And the answer is that if we walk this tree in a particular way, we can turn the notation up above into the notation down below, which is very useful to us. It can simplify things, which I'm going to get into in a minute. But the important thing, last thing to understand, is that this process, going from a string to an abstract syntax tree, is parsing, and going from the abstract syntax tree to any other form, and I chose here this particular form for the problem, which is an equivalent. But this process, from going from a tree structure to going to another representation in a string, is code generation. Okay. So yeah, so I chose the particular representation we see below because it's the exact representation that TI calculators use. So HP, I'm sorry, I'm very sorry. And that's a cardinal sin, isn't it? Okay. So like if we're like super nerds in high school and we don't have any lunch money, but we have an HP calculator, we can sit there and calculate out that problem after going through the abstract syntax tree and expressing it in the postfix notation, like so. What we need is a stack, which the HP calculator provides, and I have in brackets here on the left. A stack is just a data structure you stick stuff in, and it can go in that side and come out the same side. Okay, and you can stick in multiple items, and you can pull items out, but they all have to come in and out the same side. Okay, so we have our string that we've set there. We've parsed it into the abstract syntax tree, and then we've expressed it in postfix notation. And now, as it turns out, the calculation becomes very easy on our HP calculator. We type in 4, and then 4 shows up on the calculator stack, and then 5, and then 2, and then all these numbers on the stack. But then our input, you see, we get to the plus sign. So we hit plus, and the calculator pulls 2 and 5 off the stack, adds them together, and sticks the result back on the stack, which is 7. Okay. Now the next item is the multiplication symbol. So we hit the multiplication button on the HP calculator. It pulls the 7 and 4 off, multiplies them, and gets 28. We then push the 2 because we've gotten to another number, and then we hit the star, the multiplication again, and then we end up with our answer, which is 56. So the important thing is we've taken this representation, which if you're sitting there trying to write a computer program that's very that's trying to solve this, the general case is going to be a little bit tricky, and then we just reformulated it, to be a string that's not particularly tricky to process. But the one thing, that the point I'm trying to make with this is you have to, if you have the tree structure, you can take any representation that you choose, and you can write the tree structure out in that representation. There's some tricks that I'm not showing here, like you have to know the rules of the output language and that kind of stuff. But and you can see I'm actually avoiding the fact that there's operator precedence here. I'm very carefully picking the problem. But so now we go back to our dragons, and now that we understand that that the way you get to generated SQL is by developing an abstract syntax tree, and then walking through it recursively and elaborating that into a string. And then we also know that process is called code generation. So then we can say, well, where those dragons were is a very relatively simple thing called a code generator. Okay, so now once we have the code generator, we start thinking, well, gee, if we had some way to make those trees, then the problems that we ran into with respect to creating SQL code where we can control the actual structure of the code, that problem goes away because we can just access the code generator, pass in the tree we want, and they get the SQL we want out the back end. Okay, but of course the problem with Django is that there's no API at all for this code generator, which is what SQL Alchemy fixes. And that's the next slide, isn't it? Oh, okay. Oh yeah. Okay. So then you might think, well, okay. So here's what we want to do. We have this code generator. We know it produces a tree and then elaborates that tree. We want to come up with some way to give that thing a public API. So maybe maybe we think, well, we'll just like create nodes and then stick the nodes, as like children objects. And this model, which you can see is very clunky, which does that basically. So we start out, we create like an SQL select statement by like getting a factory that does that, all very Java-like. And then we add a parameter to that statement object, asking it for an ID. So this is how, parameters are the columns of the SQL, that's how we specify columns. So we're asking for the ID column, okay? And then we decide, well, we're going to need a where clause, and then we're going to have to add some stuff to that where clause. So we're not just going to stick it right in there. We're going to create an object, and then add that object to the statement, add the where clause object to the statement, and then create an equality object because, remember our operators hang above the operands in the tree. So we're going to create the operand, an equal sign, and then on and on. I don't want to keep on going with this, but if you actually look at the element tree writer for writing XML by building a tree, that's this syntax basically. I just took and added, changed some of the words, and that's why nobody actually uses that tree writer. So the question is, so we decide, okay, well, we have the tree, and we want to be able to manipulate that tree and generate code by somehow making that tree come into existence instead of the code generator. But we decided that just sitting here doing it the Java way is really ugly. So if we go back to that little math problem, we saw the first time the HP calculator postfix notation. Well, we could just flip the whole thing around and put the operators in front, and then we have prefix notation. And then if we take that prefix notation, and maybe we say, well, why don't we change it so like instead of like a star sign, we have a function named prod, for product, right? And some, well, then maybe put some, commas in there and some parentheses, and voila, you now have valid Python. So now you can think about it, this would obviously be in Python a very awkward way, to multiply 4 by 5 plus 2 times 2. But it's something that would work if you took, if you were to define, prod and some functions and then make them do the right thing. This is something that would give you the, 58 or something? That would give you the answer, right? So what if, since we know that this basic scheme works the same with SQL because they're both context-free languages, we say, well, why don't we just use this exact same scheme to write SQL? And as it turns out, that's exactly what SQL Alchemy does. So the expression language is the ability to really neatly and concisely describe abstract syntax trees of the SQL language. So here's an example. We take this SQL expression, and we have a where clause with two conditional nodes in it, and then we turn it into prefix notation. Well, as it turns out, like select ID from users where is all already in prefix notation. So right. So I mean, the operator comes before the operands. So we actually just have to flip around the where clause. So we see that the two booleans active, or the two tests active equals true and login is greater than the beginning of the year. Well, they're both operands of and, so we move and in front, and then we move the equality in front of active and true and etc. Okay, and then we go ahead and say, okay, well, why don't we express this in Python syntax now? Now you notice I fibbed a little bit because we actually turned the two tests back into infix notation here in the Python, and that's just something SQL Alchemy does to be nice. But the idea is valid. You imagine like as soon as SQL Alchemy gets those tests, it flips them back around and adds them to the syntax tree. But you do see that we have moved and to the beginning of the where clause. We've also eliminated from users where because that's implicit, right? I mean, we know we're accessing users because that's in the parameters list here. And well, the fact if we look up in the documentation for SQL Alchemy, we see that the second operand to the select statement is always a where clause, so we don't really have to include the where. So basically, what we're doing is we're getting rid of this. We're leaving and there, and then we're turning these back into infix just to be nice. This test and this test, we turn them back into infix, but stick them in the and statement, and obviously the and statement remains in prefix notation. There's an underscore obviously at the end of and. That's because and's an operator. You can't make it a function in Python. So I want to make sure everybody's good. Okay. Here we go. Okay, yeah, so now I just want to roll through a little bit more of how the SQL Alchemy expression language is set up. This is just that table that I was accessing, just so you can get a sense of how tables work in SQL Alchemy. This should all be relatively straightforward. If you've ever used a Django before, you've seen something like this. The important thing here, though, is we're not describing a Python object at all. We're just describing the table. The metadata object, the purpose of the metadata oh, damn it. This thing's screwing me over. Yeah, well, that's going to probably do something really crazy. Yeah, well, it should, but F5 should work too. So, okay. Nothing. There you go.
How about slideshow? And anyway, at least they put that in the same place.
Who the hell knows? Yeah. It also won't keep the right font you give it either. I figured that out. But anyway, I mean, the one thing, little bit of magic here that you see is that we have this meta object. So meta exists in other ORMs too. There's nothing explicit at all in SQL Alchemy. So the relationship between tables that exist in Python, in like the Django ORM, that's stored in that's stored in global variables. Well, that's not the case in SQL Alchemy because there's no global anything. So you actually have to create an object that just stores the state of the tables that you've loaded out of the database, and that's the purpose of the meta object. If I were to load more tables, I would use the same meta object. And then that way they could reference each other with foreign keys and that kind of stuff. And actually, if you try to load, one of the cool things about SQL Alchemy is if you have this table in the database and you want to load it into your meta object, you don't actually have to write out the constitution of the columns. You can just pass it a variable. I think it's auto load. If I had the web, I could look up. But and then that causes it to introspect the database and automatically create this table object. So I could just create meta and then have users equals. I believe I use the table. Quote users tells me what table what the table name of the database is, and then I just do auto load true close parentheses. It would look in the database, introspect it, and load users into the metadata. And also, if I have foreign keys, I have to load the foreign key tables first. I guess I don't know really what happens if you have a circular reference. That might be troublesome. But the point is, like, this is actually all part of the expression language. The SQL Alchemy actually calls this component of the expression language. They call this a data description language because what you're doing is you're describing the tables. But the point is, we're going to see in a moment how this turns into an ORM table that actually does a mapping between between the database and native objects. But the important thing to understand here is that what we're doing is we're actually describing a database table using this expression, using the syntax. Oh yeah, okay. So remember with the Django ORM, we ran into the problem where it wasn't possible for us to use a custom database feature that the Django ORM didn't support, like that PG crypto stuff. Well, with SQL Alchemy's expression language, it's as easy as just typing it in. There's there's a module in SQL Alchemy called func, and if you import func and use it, you can type in the name of any function in the database, and SQL Alchemy doesn't have to know about it because all it has to know is how to generate a call to it using the right syntax, and you just pass in your parameters, and you can see the generated code down there wraps our parameter with the function that we need to run. So my problem that I ran into trying to use PG crypto into Django ORM, it wouldn't have even been an issue. I could have just gone ahead and fetched it using the SQL expression language and not even worried about support. Yeah.
What is people.c.ssn get mapped into people.ssn?
Okay, well, so people is a table object. It's one of these. One of these. Mm-hmm. And these columns, so in this one, ID, active, last, etc., they're accessed through the C attribute of this table. So if I wanted to access active using the expression language, I do users.c.active. And then so then I can pass in to the code generator, and it understands because people is in my, I'm not showing obviously, but I'm fetching people out of the database up above. So people, I guess, the answer to that is a logical table that I've imported into the current context in SQL Alchemy, and then I go ahead and use it and I access SSN via its columns attribute. C just stands for columns. Oh, there might be, yeah. Okay. For sure. Yeah, that actually definitely makes sense. I would, yeah. Yeah, so I could have written columns there. Maybe actually I should have because that might have been more straightforward. Yeah, for sure. I've never seen that. So, right. Yeah. Uh-huh. So that's the answer to the C problem. So, okay. So I want to, first, before I get into the ORM, so one thing that we've seen in the expression language is we're now allowed to write arbitrary SQL, and we can specify using the expression language exactly the SQL we want written, even if SQL Alchemy doesn't actually understand, for instance, that that function exists in the database. We can still tell it to generate that function name. And more importantly, well, I didn't actually include an example of this, but we have the ability to make arbitrarily complex SQL. We can do sub-expressions, for instance, sub-selects. Anything you can think of that you can write in SQL, you can express using SQL Alchemy. There's no limit. There's no artificial barrier where, well, they didn't anticipate this or that, or they don't think you need this or that, or they want to do it that way, so you can't express it. Semantically, anything that exists in SQL, you can express through SQL Alchemy expression language. But then also, you might say, okay, well, sure, but I can just do that by typing SQL, right? But if we go back to typing in raw SQL, then the three things that we've accomplished by switching off, well, we're back to them. We now have to worry about parameterization. We now no longer have database syntax portability, and then we also are back to the problem of trying to concatenate strings together to generate to create generative SQL. So the point of the expression language is to solve those problems without limiting the flexibility that the programmer has to generate exactly the SQL they want. Now the problem, what the SQL expression language does not do is it doesn't take care of the record set problem. These examples all return record sets, and they don't produce native Python objects. So there ends up being a reason to have an ORM, which is to do the very last step. The one thing that ORMs can do that the expression language cannot do is actually do the mapping between result set objects and the data they're in and native Python objects. So layered on top of the expression language is the ORM, and I have some examples here to demonstrate how it really is just layered on top of the expression language. The key object of the ORM is the session object, and we create it just like this. And you can see with our user example above, well, I guess the username's changed. You can see all these examples have been very carefully checked. But our username has changed just to Jordan B, but we can now use the ORM to go ahead and fetch me into a native object as easily as we did it using the Django ORM. But suppose we want to unspool that and go back to the expression language. Well, the expression language is just barely under the covers here. So we can actually just roll back to it and use it to fetch the same, well, pretty much the same data. We just have to know that where things have been stuck. So to get the expression language connection, we need to do engine.connect. You probably saw it in previous examples, previous example slides. Well, the engine is actually just a sub-component of session, so we can still fetch a connection pretty straightforwardly. And then we can sit there and execute a standard query using the expression language. Now, remember, we were accessing users lower, and by convention, I had a lowercase object for the user table. Well, this user object isn't the user table anymore. This is a native Python object. So the question becomes, well, if we're using the expression language and we want a result set back, we have to go from using the native Python object back to using the table. Well, as it turns out, in the SQL Alchemy ORM, the table component, the data mapping component of the ORM native object is just in this underscore table guy here. So we can just poke down inside the user object and fetch this table out that way. And this slide might have been better if it was before that slide. This slide is a demonstration of how you create this user object, which is to say a user object that maps the table up above. God damn it. That maps the data represented in this table into a native Python object. And to do that, we use the declarative base. And we establish a declarative base. This is another thing that would have been kind of global in the Django ORM. If you ever have used Django, you know you have the subclass models.model. Well, the declarative base is just models.model. Django or SQL Alchemy uses this little factory guy here, so you can pass in if you want to modify it. But then the rest of this should actually look a lot like active record or the Django ORM. One big difference between them and this setup is that we have to specify a table name. That's because SQL Alchemy isn't even remotely opinionated. Everything where Django or whatever just does something, you have to specify it in SQL Alchemy, which is actually kind of nice, especially if you're mapping. If you're mapping to existing data in the database, of course, or into an existing schema, you can still go ahead and do that. Right. Okay. So then this is the killer feature, I think, of SQL Alchemy. So what we've seen is, actually, I'm going to fetch the last slide. So we've seen that the structure of SQL Alchemy looks basically like this. It looks basically like the structure of the Django ORM, or pretty much any other ORM, with the difference being that this little dragons thing in Django, here in SQL Alchemy, this thing has its own API, and it's actually a pretty nice API. Okay? And we've also seen that the layering of the ORM on top of the code generator is a very thin layer, and it's easy to poke down into the expression language. So then, the end result of that is that it's very straightforward when you're using even the ORM just to go ahead and fall back into the expression language whenever you feel like it. And I have two examples here. The first example, we actually kind of pop into the expression language twice. First of all, we decide we need an order by statement. Maybe almost 3 times. I don't know. I guess the order by is, that's part of the expression language. Yeah. So we sit there and we do session.query. So we're going to fetch something out of the ORM. We pass in the user object. We're not using the table thing because we're using the ORM. So we use table, and we don't even have to specify that C thing anymore because that's a table thing, not an ORM thing. User is an ORM object, so we can access it the same way we'd access a Django ORM object. Filter, well, that should be familiar to people who've used ORMs before. But then we can sit there and pass in, something that looks like it came out of the expression language. But this will just go ahead and work. Order by, that comes from the expression language, and this desc function stands for descending. And notice that this is back into prefix notation. In SQL, I think desc usually comes up like the select statement or something, isn't it? No, I don't know. But, right after whatever the heck you're ordering. Right. Okay. So we just flip it from postfix to prefix notation. But But whenever you run into one of these things, it always goes into prefix notation in SQL Alchemy unless they special cased it. So, we started off in the ORM. We've now gone to the expression language to tell it how we want it ordered. And then we're going to hang out in the expression language to tell it that we actually also only want the first 20 records. Because we want to see the last 20 people who logged in. So here we go. We're just hopping in and out of the ORM. And like the opinionated bit of this whole talk, and the kind of reason I wanted to give this talk is, if you were to go through the Django ORM tutorial, it wouldn't show you it using any of this stuff. It would show you, with quotes and raw SQL in there. The reason why is because I guess they've decided that people can't figure out the expression language. So they're just going to show you, okay, stick some raw SQL into here. Of course, then we're back to the original problems we have with writing raw SQL. And it's not necessary, as shown here. Because the expression language gives you complete control over the code that you generate, there's really no reason at all in SQL Alchemy to ever write any raw SQL. If you're writing raw SQL, you're doing it wrong. And if you have a code database that's in SQL Alchemy and it's using the ORM and there's a lot of raw SQL in it, anywhere you see that, you can just take it and rewrite it in the expression language. And you can write word for word, component for component, the exact same thing in the expression language. And so then to kind of bring up that crypto example again, let's suppose we have the ORM and we have a people object in there with an SSN field like we saw before, and that SSN field is encrypted in the database. And we actually want to select a user with that particular social security number. So we want to decrypt the SSN field in the where statement of the SQL and then match it against some user input, which I didn't specify here. So, oh, God damn it. Okay, that's all locked up. So imagine, actually that should be PG sim decrypt. And then, so we've decrypted the SSN, and then we can just do equals the user supplied SSN that we're trying to look up. And then if it exists in the database, that one will return that one item, and if it doesn't, it will return none. But the important point is here that we don't have to have any anything that extends SQL Alchemy to do this. We can just go ahead and do it using the func tool. And in fact, I'm using in a project that I use SQL Alchemy for, I was using GeoAlchemy a great deal. And it confused me at first because the GeoAlchemy, the ability to make comparisons in GeoAlchemy is extremely limited. There's a whole bunch of stuff that's missing. If you've ever used the Django geocoding software, you find that there's a whole bunch of extensions to the object that allow you to make all kinds of different comparisons, right? Well, none of that really exists in GeoAlchemy. There's a few things. And when I first started using it, I'm like, well, man, they kind of only did half the application here because all they provided was the objects, the ORM objects, the column types, basically. And then I ended up realizing that the reason why they didn't provide the functionality to do the comparisons is because the understanding will be that people would just use the func interface to just go ahead and call the PostGIS functions that they're trying to run. And actually, the only thing that I ended up using GeoAlchemy for at all was the data types that it created. It was completely irrelevant to me, for accessing any of the other features of PostGIS. That's basically the spiel of this talk. The opinionated bit in the title card is that the expression language is really a core aspect of SQL Alchemy. It's the killer aspect of SQL Alchemy because it takes the one thing that really ORMs killed, which is the ability to generate custom SQL code, and it gives it back to the user without having to have them resort to writing raw SQL. So that's the talk. So the question is this already in Django? I don't. It definitely does not come with Django. Django has its own ORM. but because you can reflect objects out of the database, it's kind of an open question. I don't know. I haven't ever tried grafting SQL Alchemy onto a Django project, but I can actually see a lot of instances where it'd be useful. If you think about it, like typically you have a Django CRUD application that is very simple on the front end, and it's just sticking data into the database and pulling it back out. But then oftentimes you have a back end that exceeds the custom Django admin. You have other things. You have particular reports that you need to have run that maybe need to have subselects and that kind of stuff. And right now, if you look at a typical Django application, either it's incredibly inefficient at doing that. It's pulling data out and then trying to correlate it in Python. I've done that before. Or you have people writing raw SQL using the connection.execute stuff that Django provides. And it seems interesting to me because with SQL Alchemy, you can just sit there and reflect the Django tables out of the database into your meta object and then just sit there and start running queries on them. I think definitely the next time that I run into that, I'll probably just go ahead and import SQL Alchemy, reflect that data in and run the query. So I guess in answer to your question, no, Django does not support SQL Alchemy, but SQL Alchemy is so powerful when it comes to reflection of data out of the database that I don't think it would be very hard to just go ahead and access the Django data. So.
Well, do you have problems setting up custom forms and stuff like that are driven from the database? Then wouldn't you? We would be able to use those features.
Yeah. Well, so I guess what I'm imagining here is the situation where you continue to use the Django ORM on the front end, and then you're only using SQL Alchemy for those aspects of, for the reports that you're having to run for the back end for the product people, for instance. But you're right. The forms API of Django doesn't work with SQL Alchemy. There is an SQL Alchemy-based form generator, which might be an option. I mean, you might just go ahead and say, well, this actually works. I'm just going to sit here and use SQL Alchemy's form generator for my model forms. I've not tried that, so I can't really speak to that, but I know it exists. Oh, it is? Yeah, so it's apparently not maybe ready for prime time. Yeah. And I have to say, you're just saying that it doesn't give you a lot of access to the features of SQL Alchemy. With the application that I use SQL Alchemy for, I use WTF forms for the forms I needed to generate, and they don't really give you. I mean, it's not model forms at all. It's like the classic Django forms where you have to pass the data in and not yourself. But that's what I ended up doing. So yeah.
Does using SQL Alchemy introduce any overhead or any significant overhead, especially if you're doing large table data copies or loads, things like that?
Well, so the question is, does SQL Alchemy introduce any overhead? And I do know I know that people who are trying to use SQL Alchemy with Tornado, not Tornado. It works fine with Tornado. With Twisted, ran into problems where the setup and teardown of the ORM in each little Twisted process, was very expensive. But they could use the expression language. The only overhead of the expression language is making the connection and creating the meta object, which isn't very big. So, so I would say that the expression language is fine for tasks where you need inexpensive, setup and teardown processes. But the ORM, I understand, when you create that session. When you create the session object using the session maker, a whole bunch of stuff happens that is pretty expensive. Now, with respect to bulk updates and inserts and all that kind of stuff, SQL Alchemy is amazing for that. I mean, it's supported that since day one. So you can do, like I said, any any code that you can generate using by writing raw SQL, you can generate that code in SQL Alchemy. And if that's a bulk 2,000 inserts all in one connection, sure, that's no problem. Yeah.
How well does it deal with like huge record sets? Let's say, for instance, you execute that select statement, it comes back with 2 million users. Is it going to try to load everything to memory, or does it give me something where I can iterate through?
Well, so the record set, so the question is, suppose I have an enormous data set that I select all the records in, and then I want to iterate through them to try to load everything into memory. The answer is actually you have a lot of control over that. In the expression language, you just get back the result set object that the database API returns, and the result set object doesn't load everything all at once. So, so if you're using the expression language, there's absolutely no problem. Now the ORM does try to auto-load things, but you can turn that off. And actually, one of the cool things about the ORM is, if I don't use an example with the foreign key, which maybe I should have, but you can actually specify in the foreign key, by default, it'll try to auto-load the data on the other end of the foreign key when you load an object. But you can tell it not to, and you can do that when you set up the relationship. So for instance, I had a user object that had like a log table attached to it. And of course, that log's going to be enormous very quickly. And I don't want it to load that into the data into memory every time I try to load a user. So I just set the relationship to manual load only. So then the relationship still existed, but it never actually tried to load that data. So.
I think he was more referring to database cursors, if I'm not mistaken, but it goes for that.
Database cursors? I'm not familiar.
Correct me if I'm wrong, isn't that where you look at one record at a time and it iterates through and loads it as you need it? Sure.
That's what the record set does, doesn't it? Yeah, the result set. Yeah.
I want records 300 through 500.
Yeah, well, I had the example of the limit, and of course, I can't remember. I'd have to look up exactly how to do that, but it's definitely possible. What is it? Yeah, so .offset.limit. Yeah, so no, that's very easy. Like I said, if you can express it in SQL, if you can express a query in SQL, you can express it in the SQL expression language that SQL Alchemy supports.
So not every database supports limit.
If the database doesn't support it, all the expression language is doing is generating SQL. So if the database doesn't support it, then it's not going to be available. So.
Well, they might support it, but not through the limit keyword.
Oh, in that case, yeah, if there's an alternate, then usually most database backends to SQL Alchemy. I mean, I've seen, they were showing examples, I can't remember where, but some of the stuff that it was generating for Oracle is really bizarre. I mean, stuff like code that doesn't even look like SQL, because
there's a separate compiler for every single database backend. Some of them use a lot of the generic stuff, but then there are special things for like Sybase.
Yeah, and you can see that in my little diagram. I show like 2 different backends for Postgres and my. And you can imagine Oracle and like this. Even isn't there like Fire? What is that, like Fire whatever database?
Firebird.
Yeah.
Akimba now.
Akimba, yeah. So I mean, it makes you wonder if they can start putting it in front of like the NoSQL stuff. I would imagine. Oh, well, there you go. So yeah, so you can use SQL Alchemy in front of Mongo. So. It's used. It's been around for a long time, and it's used in actually a whole bunch of places. If you ask around, you'll find that people have been using it actually quite a bit. I mean, it was around before the Django ORM, mostly as the expression language. They hadn't really gotten the ORM working yet for it. So Django's taken a big chunk, I think, maybe of new applications, but it's definitely a very popular Python application.
Did Turbo Gears use it as their thing?
Turbo Gears, yeah, I believe so. Or no, they used SQL Object, didn't they?
Oh, that's me.
Oh, okay.
Kevin said.
Yeah.
They were using SQLAlchemy, they were using SQLAlchemy before.
Okay, yeah. So I guess they switched from SQL Object to SQL Alchemy.
Big project, that's all I can think.
So is that it?
So is there a strict set of, if you want to be able to switch between databases, or you want to improve, to just use the subset that works universally, so it's some sort of set?
You mean, so I can say only answer, yeah, so the question is, can I enforce database compatibility by disallowing any feature? And the answer is no, because I mean, like these functions you saw in the func thing, SQL Alchemy doesn't even know if that function exists. I could write func.foo_bin_bar, and it's just going to yeah, so it has no idea. I mean, presumably if you're using a custom extension, there's a reason to, right? So, I mean, I guess you're hopefully knowingly giving up cross-database compatibility for that. I mean, one thing that, I mean, the key thing with SQL Alchemy is that there's a lot of obnoxious incompatibility between databases. Syntax is just an obnoxious thing. There's just two different ways to express the same thing, but that's something that you run into if you ever try to move databases. And yeah, SQL Alchemy does solve that problem.
What about something like vertical partitioning where you're trying to select the entire hierarchy versus like column only, where you only select the
Well, you can do unions. Is that what you mean? Or
No, okay, so I guess in like Postgres, you can inherit from a parent table, and then when you select on the parent table, you automatically select the children table because you do Chrome only on the parent table, and only select that parent, new parent table.
well, you can. I don't know. I may not be aware of that feature. I know you can do any kind of like aliasing subselects. Selecting out of select statements and anything like that.
Aren't you just like talk about the feature of the ORM where you start with the parent table and drill down and methods and like
Well, I mean, it's not like a join table, it's like almost like
That's not the
database layer.
So you're talking about concrete pairs. In the SQLAlchemy language, vertical partitioning is going to be like having tables on different servers.
No, in Postgres, you do vertical partitions on the same table, on the same server, actually. And it makes the indexing more efficient. You can indexing to memory based on some constraint.
I would expect. I mean, one thing I can tell you is that if you look at the expression language API, there's a huge number of different things you can add to it. I mean, one thing is store procedures. Some databases have store procedures where you have to pass in an out parameter. And they support that, and that's, pretty crazy. So I would be very surprised if it didn't support that, if Postgres supports it. But I'm not aware of how that works exactly. But, so what you're saying is, well, and also one thing I can tell you is that, I mentioned that the expression language is flexible. The data description language, and the layers even below the expression language API, like variables, components that you can use to create new tokens that end up getting elaborated. That's all part of the public API as well. So and as an example, the migration, SQL Alchemy Migrate, the migration package that I use, adds some alter table or alter table column behavior, that's not supported in the standard SQL Alchemy DDL, and it's able to do that through public APIs. So even if that's not supported, I'm sure it would just be a little bit of poking around to figure out how to add it. Is that it?
Thanks, Ryan.
Uh-huh.